Hello, everyone, and welcome to class. Today we are talking circle theorems. This is part one of a two-part lesson. In this lesson, we are going to be going to review basic angle and triangle properties, and as well as parts of a circle, to discover and state the circle theorems and review questions related to circle theorems. We're not going to do all of them today. We're going to go through three of those theorems. And in the next lesson, we look at cyclic quadrilaterals and tangents to complete the set of circle theorems. So before we jump into what circle theorems are and demonstrate anything, let's talk about some things that we need. We need to remember that in a circle, our angles add to 360 degrees. So angles at a point, when you add them up, you get 360 degrees. This is important to remember since we're going to be working with circles. Angles on a straight line or straight angles measure 180 degrees, and so is the sum of angles in a triangle. When you add those, you get 180 degrees as well. Three other facts. Angles in an equilateral triangle are 60 degrees in size. This is so since our triangle, when we sum them, we get 180, and dividing that three ways, we get 60 degrees each. Angles in an isosceles triangle, two angles in an isosceles triangle are equal, or usually the base angles, or whatever sides relate to the equal sides. So this side and this side are equal. These two angles relate to them, and so they are equal. And angles in a quadrilateral measure 360 degrees. So all these little things are important when it comes to dealing with and making the most sense of circle theorems. Now let's look at parts of a circle. Remember this whole line that defines the circle. It's called the circumference. We won't be measuring it, but we will be using it. If you use a straight line to cut off a part of a circle, that part that you cut off is called a segment. So right here, this part is called a segment, and that line is the chord. If the line is drawn through the middle of the circle, it becomes a diameter. It's very important. And of course, the center. And any little straight line drawn from the center to the circumference, we call it a radius. And the distance between two radii, we call that an arc. So very important little ideas that we need to remember. Again, we are going to be working with circles, so those things become important. So what on earth is a theorem? A theorem is a mathematical statement that we can prove. So you might think of Pythagoras' theorem. Other theorems exist. Anything in mathematics that you can prove, we tend to call it a theorem. And so circle theorems are those provable statements about circles. All right, now that that is out of the way, we are going to be looking at three basic theorems. First one is that angles drawn in the same segment of a circle are equal, keeping them very simple here. The angle at the semicircle is twice the angle at the circumference, and the angle drawn in the semicircle is a right angle. Now we're going to demonstrate all of that by switching to another app here and drawing those circles and showing you how it works exactly. So let's draw a circle. And this is our circle. Let us now draw a triangle on this circle. So I'm going to just draw a triangle here. Let's fix that. Okay. Let's clear that and start over. So I'm going to draw back this circle here. All right, here's my circle. And now I want a triangle. So I'm going to draw that triangle on the circle. Very good. Here we go. That's nice. And I'm going to measure this angle up here. Now, the angle up here, the size of that angle is as it is, 61 degrees. I'm going to draw another triangle on this. Notice right here, this is a segment. This is also a segment. This is also a segment. I'm going to draw another triangle on this line. So here we go. So now I have two triangles drawn in this segment. So we have this segment cut off, and the other segment tends to be called the alternate segment. So it's also a segment. Here's a segment, up there's a segment. Notice that the angles are drawn touching the circumference. That is very important. I'm going to measure this angle too. And measuring this angle here, you will see that it has the same size as the other angle. And it doesn't matter how many angles I put up there. If I want to draw another one, I could very well do that and put that on the circumference. And here we go. Also, let me measure it. There we go. Notice that they're all the same size. And it doesn't matter where in the circle that you put the angle. It doesn't matter rather where in the segment you put the angle. So if I choose to put it all the way down here, it doesn't matter. It's still the same size. If I try to push it over to the other side, it doesn't matter. It's the same 61. And so you see here that any angle that is drawn in the same segment, they are equal to each other. So let me move this, and you can see the angles changing in size. So as long as I stay in the same segment, notice, as long as I stay in the same segment, all the angles are the same size. It's very, very important to see there. Notice how the sizes keep changing as I shift it, but they remain the same size. And this is to show you how exactly it works. It doesn't matter, this is our segment that we're using. This line is our segment that we're using, and these are the angles, the three angles that are drawn on it. So they are all the same size, and this is a demonstration of the theorem that angles drawn in the same segment are equal to each other. Sometimes some persons say angles drawn on the same chord, because this is a chord and these angles are drawn on it. Notice that the legs of the angle rest on this chord. These two legs rest on that. These two rest on this one. The legs all rest on the same chord. Sometimes people say angles drawn in the same segment are equal. Sometimes people say angles drawn on the same chord are equal. It's basically the same idea that they're expressing. So that's that. Angles drawn in the same segment are equal. Now let's jump back here and talk about our questions a little bit. So if angles drawn in the same segment are equal, then what is the size of angle A here? Then notice that this line here would act as our segment. It's not there, I'm just putting it in with a broken line, so you can see these two angles, A and 27, are drawn in the same segment. And so because they're drawn in the same segment, then angle A here is going to be 27 degrees. The same thing happens on this side of the circle. So if you should pop a segment here, then what you will notice is that these two angles, B and 30, lie in the same segment as well. So B would actually be 30 degrees. So B is 30 degrees, and up on this side, A is actually 27 degrees. Going over here, you can see the idea again. These two angles are in the same segment. Therefore, angle C is equal to 20 degrees because angle C would be equal to this angle here. And on this side, angle D would be equal to 45 since they're both drawn in the same segment. All right, let's go back to our next screen and look at how we prove the other theorem, or how we demonstrate the angle theorem, that the angle at the center is twice the angle at the circumference. Let's get back to that. So this is where we're showing that angles drawn in the same segment are equal. Now, let me clear this and let me redraw my circle. If you're curious about this app, it's called Cabri Geometry. It's a free app. You can download it and use it to play around and demonstrate and mess with and improve your learning. So now I'm going to draw a triangle coming from the center of my circle. Here we go. That's my triangle. And now I'm going to draw another triangle This one comes from the center. I'm going to put in another triangle that comes from the circumference. So here's my other triangle. So here I have two triangles, one coming from the center of the circle. So it starts with the radius, radius, radius. Notice this triangle is an isosceles triangle because the radii here are equal. So let's measure and see exactly what the sizes of these angles are. This angle at the circumference measures 59 degrees, and this angle here at the center is going to be measuring, all right, it's a little bit off now. I think as soon as I start moving it, you'll notice that it changes. So um, okay, let's go with it. Very good. There we are. There we go. So notice that the angle at the circumference here is 62, and the angle at the center is 124. So this angle is twice as big as this one. Now, if I keep moving it, 136, let me make it smaller. So here, when we have it to be 80 degrees, you notice that the angle at the center is 80, the angle at the circumference is 40 degrees. And if I move it even smaller, then the angle at the center being 30 degrees and the angle at the circumference being 15 degrees. So we can say it that we can see that the angle at the center here is twice the size of the angle at the circumference. So 2 times the angle at the circumference would give you the angle at the center, or the angle at the center divided by 2 gives you the angle at the circumference. Either way, and you see the same result. And if I should put another triangle up there, then the same thing is going to be true. So if I should draw another triangle on that, then it kind of look like the first theorem, just that the first theorem wasn't drawn from the center. So if I should measure this angle here again, then you're going to see, let me measure this angle, starting here, this point, and there. So you see that both of them, once I start moving it, there's a little bit of discrepancy in the thing, but once I start moving it, then you will see that it turns out it corrects itself. So 64, 64, 128. So the angle at the center is twice the angle at the circumference. The angle at the center is twice the angle at the circumference. Now let's jump back to our board and look at how we can practice a little bit of that. So if the angle at the center is twice the angle at the circumference, then this angle is 84. It means that this angle B is going to be equal to 84 divided by 2, or half of 84, which gives us 42 degrees. Similar thing here. Here we have the angle at the circumference, and this angle G is the angle at the center. So angle G is going to be equal to 2 times the angle at C, which is 2 times 38, which would give us 76 degrees. So angle G would be 76 degrees. Angle H relates to something that we learned from previous years, that here we have a triangle. And by the way, angle G is also called angle BOA. Let me just write that in. And angle B here is also called angle ABC, using the convention to write down the angle. So the next angle we want to find, angle H, which is angle OAB. Notice that this is a triangle. It's a special triangle. It's an isosceles triangle, given that this side is equal to this side. So because they're both radii. So this angle here would be equal to that angle here. And since we know that angle G, which is BOA, is 76, then we can say 180 minus 76. That gives us 80, Yes, 6 from, that leaves 4 and 104 degrees. And now we can divide that 104 degrees into 2. And that would give us 52 degrees. So H would be 52 degrees as well as the other angle there. So sometimes when you're doing the questions, other things will be thrown in. But the idea here is that the angle at the center is twice the angle at the circumference. Let's get back to our app to look at this again. Now, using the same idea, what if I make this line, move it until I get a diameter? Now, let's move it until I turn it into a diameter. Right now, it's just 2 random radii that are making an arc there. What if I move it and make it into a diameter? What would happen? Now we know it's a diameter when it turns 180 degrees, because 180 degrees is half of the circle. Now, if you notice here, I have carried it right along the diameter. This is the diameter. And notice up here that the angles in the semicircle are both now 90 degrees. So this tells us clearly that the angle drawn in the semicircle is a right angle, which is half of this, which makes sense because the previous theorem said that the angle at the center is twice the angle at the circumference, which means that if this angle here, which is now 122, 28, 1, if I move it up all the way until it becomes 180, then the angle at the circumference is going to be a half of 180. And a half of 180 is 90. So the angle at the semicircle, the angle at the circumference here is now 180, which means the angle at the center is 180, so the angle at the circumference would be 90. So the both theorems relate in a way. One is just an extension of the other one. So you see it here that once you draw a line, a diameter, any angle that you draw on that diameter touching the circumference has to be 90 degrees, and it doesn't matter where on the circumference you draw it, as long as it's drawn on the diameter. Notice that it is still 90 degrees. So the angle drawn in the semicircle is a right angle. Those are the 3 theorems that we wanted to look at today. And I'm going to jump back to the board now and look at our last little bit of practice questions. So here in this question, we have angle BCA or ACB. If you wanted to find the sides of ACB, notice it's drawn with a curved line, which makes sense. Sometimes the question just doesn't want to give it away, so you don't want to put the right angle symbol there to show you that it's 90. But notice that this line is a diameter. It's important that you notice that the center of the circle is there, and this line AB is drawn right through the center. So this AB is the diameter, which means that the angle drawn on that line is actually 90 degrees. There's nothing to work out. It's just something you know, you remember, you write down. All right. For this one, we want to find the angle X. Now, we know that this angle here is 90 degrees. And what that means is when you add those 3 angles, you should get 180 degrees. Or since this angle is 90 degrees, these other 2 angles are going to be complementary to each other. So we can say angle BA, the angle at, well, there's no letter here. So let's use angle X. So the angle X can be equal to 90 minus 72, which is equal to 18 degrees. Or you can use the fact that X plus 72 plus 90 gives you 180 degrees, and use that fact to work it out. Either way, X is going to be equal to 18 degrees. So these were 3 theorems that we looked at today. In the next lesson, we're going to be looking at the other theorems, which have to deal with tangents and cyclic quadrilaterals. So let's quickly look back at our theorems. 3 of them today. Angles drawn in the same segment are equal. The angle at the semicircle at the center, I keep saying semicircle, the angle at the center is twice the angle at the circumference, and the angle drawn in the semicircle is a right angle. So these are the three theorems we went through today. I hope this video would have made some sense to you and helped you in your understanding. Look out for our next video where we'll talk about cyclic quads and tangents. Thank you for watching.